Hi, my name's Ian Leifmans. I'm an artificial intelligence fellow from the New York cohort, and today I'm going to be talking to you about my project SCINet. So 50 million people a year experience acne, but only 5 million people a year actually seek professional treatment. That's only 10%. So obviously there's a huge gap between the people affected and the people actually receiving treatment. On top of this, we're in the midst of a global pandemic. There's a huge demand for remote treatment right now. This is where the company I consulted for called CureSkin comes in. CureSkin provides remote medical treatment by leveraging AI. What they do is you send them an image and they detect and categorize the skin conditions on your face. They send these to a doctor who prescribes you with a treatment plan, and you come out with great looking skin. But how do we know that the treatment is working? Identifying persistent conditions is essential because it could be the difference between continuing or altering treatment. CureSkin is trying to automate this process of identifying persistent conditions. So to be exceptionally clear, what CureSkin has is a model that identifies and categorizes skin conditions. What they need is a way of tracking skin conditions over time. So to give you guys an example with regards to acne, given two images from the same patient's face at different points in the treatment plan, does the instance of acne identified in one picture correspond with the instance of acne identified in the other? To give you guys a quick visual of what SCINet does. So first, it takes the two images from the same patient's face at different points in the treatment plan, but it also takes in the corresponding annotations and bounding boxes for the identified skin conditions. You can see these here in red. Now, what it does is it matches the boxes that correspond. In other words, these two instances of acne are the same in both images. These are the persistent conditions. So for my pipeline, the data is stored in an S3 bucket. The model is run on the EC2 instance. It's containerized using Docker, and it outputs predictions to CureSkin. For my data, I have over 200,000 annotated images, and each patient has a timeline of roughly 10 to 15 images. For my model, I leverage pre-trained models from both DLib and OpenCV. First, I detect the faces, then I identify the facial landmarks. I use these facial landmarks to align the faces as such, and then I stack two images on top of each other and match the corresponding conditions with a custom metric. So what's this custom metric I'm referring to? Because there are no ground truth labels, I need to be exceptionally clear and very careful with how I design my metrics for success. So my metric is a combination of intersection over union and confidence. Intersection over union being the degree to which two bounding boxes overlap, and confidence being how sure we are that corresponding to and matched conditions are in the same relative position on the face with regards to the facial landmarks. So for performance, I can't necessarily show you any images because of privacy concerns, but I can dig in a little bit to the metric. Intersection over union is a bit low, and this is not surprising though, because oftentimes conditions change, shift, and morph a bit over time. The confidence is a lot more encouraging, however, as this is essentially indicating that the matched conditions, we can be relatively sure that they are in the same relative position on the face with regards to the facial landmarks. So to really check the performance, again, because there are no ground truth labels, I had to check performance by hand. So I evaluated over 400 image pairs, which essentially results in being 95% confidence that these results reflect the results within the population. So for accuracy, 67%, precision was 98%, and recall is 15%. Now, I'd like to tell you guys that CureSkin was very interested in maximizing precision. And the reason for this is because false positives are much more harmful than false negatives. Say, for instance, you identify a condition as persistent and it's not. That could possibly mean changing the treatment plan and exposing the patient to unnecessary risks in terms of reaction to the treatment. If you do the opposite, however, and you identify a condition as not persistent when it in fact is, we can always get it on the next go around or the next checkup. So that's the reason for this. So CureSkin was exceptionally happy with these results. Obviously, the recall could be improved, but the precision of 98% is awesome. So to give you guys a quick rundown of overall how the model did, there's no training, there's no low latency, and it's simple yet effective. There were some cons, however, and these were reflected in the recall score. It didn't deal well with occluded conditions, didn't address spatial variance, and sometimes it failed to detect faces at different angles. I did present CureSkin another iteration of my model, which was a custom deep learning solution. It involved using a bi-autoencoder to attempt to address the spatial variance and occluded conditions that plagued that recall score. There's There's not enough time to necessarily go into this, but it was something that I did want to mention because Kirsten really loved the idea and thought it was somewhere to go possibly down the line when continuing to iterate and improve upon this model. So thank you again for listening to my presentation. Again, my name is Ian Leifman. I graduated last May with my master's in economics from NYU. Whether it's in sports, in schoolwork, or whether in the workplace, I love and thrive off teamwork. I also have a background in healthcare economics from all the economics classes that I've taken throughout my studies. And I also have a ton of allergies. So I'm very aware of how essential it is to get everyone great and accessible healthcare, which is actually what pushed me towards this project. And this is the same passion that I would love to bring to CVS, as well as my skills in machine learning, statistics, and economics. So thank you again, and I'd be happy to take any questions at this time.